From the previous video, we have all the scatter plot we changed to the standard unit. The reason is we will calculate the correlation coefficient. Correlation coefficient is the measurement of the linear association. The coefficient correlation, we're using the R to stand for that. You can see correlation coefficient, kind of need to talk using your tongue a lot. So that's why in the statistic, when you just say R, we all know that's the correlation coefficient. So the coefficient correlation R using to measures linear association. So they are based on the standard unit. Your coefficient correlation R always between -1 and 1. The reason is we all change to the both numeric variable using the standard unit. So the standard unit by definition is we're using the original unit minus the average divided by standard deviation. So that's why when we calculate the R correlation coefficient, they will always between -1 and 1. And some important number for the R can just right away let us know the relationship between these two numeric data. The first one, if your R exactly equal to 1, that means the scatter is a perfect straight line, slowing up. So that means you can just have one straight line and all the data, all the dots from the scatter plot is all on this line. No one missing. All the data is on that straight line. So that will have our R equal to 1. When your R equal to -1, actually you are still perfect straight line. The only thing is they are not slowing up, they are slowing down. So we have a negative slope straight line. And all the data on the scatter plot is on this line. So that's R equal to 1 and R equal to -1. However, if your correlation coefficient R is equal to 0, they have no linear association. On the other hand, they are totally uncorrelated. So what does that mean? We see the demo, we can see different plots. Okay, so from earlier, you can see we have our hybrid data, we all change to the standard unit. But later we will show you, we will calculate their coefficient correlation coefficient R. So that's why we're just using R, correlation coefficient. Okay, so that's why here, if you want to see how the scatter plot look like for your correlation coefficient, okay, so one thing is you can just using R_scatter. Okay, you provide the R value you want. So here, for example, when the R equal to 1, that's why you can see they are exactly all the data, all the dots is on the straight line. They are not missing any dot. So then here, if you want, you can change the data. So for example, we just change, we're using the positive for now. Okay, so that's why if you see you change to the 0.9, they still can see they are close to have a straight line. But you see this straight line actually have some noise, right? They kind of allocate, we can see this straight line will be good fit for our data. But they have a lot of data just not really on this straight line. But just mostly we can see they are like that. Okay, so then if you have your R positive but less than 0, sorry, less than 1, greater than 0. Okay, so when they become smaller, actually they have more data. Actually, they are kind of not really, you can see they have the pattern kind of the positive relation, positive association. But one thing is if using this straight line to represent that, but they still have a lot of distance from this straight line. Okay, so the same thing we see if you have the R equal to -1. Yeah, they are perfect straight line. and all the dots is on this straight line. So the same thing, if you have r equal to 0, how they look like? Yeah, you can see totally, you are not really know, I have the straight line this way, or this way, or this way. So that's why we say they don't really have the linear relationship. They are totally unrelated. Okay, so the same thing here, we have, remember earlier we told you, they have 3 numbers very important. Positive 1 or negative 1, they are all perfect straight line. Just one thing is, positive 1 is positive slope. Negative 1 is negative slope. When you have r equal to 0, they totally have no linear association. And not only we can show you, you can see that from Python, we can just show you the plot. Okay, but also one thing is, continue, we told you the definition for our correlation coefficient. So the definition for the R, how to calculate the R. R is the average of the product of the standard unit. So that means you have 2 numeric data x and y, right? We need to convert both both numeric variable into the standard unit. Then they multiply together. Then we find the average. So this average is our correlation coefficient, because this calculation may then always greater equal to 1, or greater equal to negative 1, or less than equal to 1. They are between only negative 1 and 1. So they measure how clustered the scatter is around a straight line. Yeah, so you can try different numbers to see how the scatter plot look like. But now we're just using one example. We see how to calculate the correlation coefficient R. So we make 2 numeric data. The first one, x, is only just 1 to 6. So then we kind of just mix up our y. Okay, so that's why you can see the table. We have 6 points. So we make that scatter plot. So that's why you can see you have 6 dot. Okay, so then we can calculate the standard unit. Because in order to get our R, the first thing we need to convert x and y become standard unit. So once they convert to the standard unit, okay, so that's why you can see they have some standard unit is x is negative, some are positive. The same thing for y. So when you scatter this 6 points again in the standard unit, they still look like the same as before, right? But just one thing you see, the unit is different. Okay, so now if we try to calculate the R, the average of the product of the 2 numeric variable in standard unit. Okay, so that's why here, that's right. Okay, so one thing is, like we say, the product of the standard unit. Okay, so we just calculate each one. Okay, so we add this one to the next column. Okay, but this one just the product of the standard unit. So we need to add them together. Then we find the average. Okay, so that's the average for that. So we're using the NumPy average. So that we have that. So then you can see the standard unit is about 0.617. Okay, so that's for this one, for this 6 dot. So the same thing, since we know how to calculate the R, how about we just write that in a function? Okay, so in this function, we try to find the R correlations. So you pass in the table and the 2 numeric data you want to find the correlation coefficient. Okay, so the first thing we need to make our x into the standard unit. The same thing, y in the standard unit. So then we just multiply them together, then we find the average. Okay, so that's why here, since you have this function, so earlier we have our table, right? So we have 6 dot. So you can see, right, we have the answer the same. So the same thing, let's find our coefficient, correlation coefficient R for earlier our SUV example. Okay, so we have our scatter plot, right? Remember we have our MSRP for our SUV and our gas mileage. So remember earlier we said they are kind of negative association, right? Okay, so then let's find our correlation. So that's why we passing the table name. Then we passing the two numeric data. So then we can find their R, correlation coefficient, right? So you see here, right, because we see they are negative association. So we do see kind of have a linear line or have a line here. Okay, so then we can see, right, they do have the negative R. Okay, so the same thing we can do more. Okay, so earlier we still have our acceleration for our MSRP. Also remember that's our earlier our acceleration and our MSRP. So right, they kind of, since they have more on the left bottom and more dots on the top right, they kind of is positive association. Okay, so the same thing. Can you find the R? Right, so we just call the correlation function, right? Earlier we defined. Okay, so we passing the table name, we passing our two numeric data. So you can guess the R will be what? Positive or negative? Right, so they are positive. Okay, but you can see even they are positive, but we know they are not really fitting the straight line for all the dots. Okay, so then kind of you have more data outside the line. So that's why they are positive, but they are not close to 1. They are a little smaller size of the number. Okay, so that's our example about our correlation coefficient. So earlier we talked about association is the two numeric variable. And we have the trend for the positive association and the negative association. So that association, if we want to like quantify that, so then we can use the correlation coefficient R. So the calculation will be the average for the product of the two numeric data, but in the standard unit. So that's our lecture 29. So afterward, of course, make sure you take your lecture video quiz. And this week, we will be a little different. Yeah, we will have our project too. We don't have lecture, we don't have lab exercise. Instead, you will start working on your project too. So then you have the project 2 worksheet to discuss with your peer group. So this week, you only need to submit by Sunday. By Sunday, we submit only the assignment, this week assignment. Okay, about the project 2, please start working on that, even you don't need to submit this week. Because this one needs more time to work on that. So check the deadline for your project 2 and start working together, discuss with your peer group. And even you don't need to submit this week, please make sure to start working on that and discuss with your classmate and peer group. So that's our lecture 29.